It is a mind-reeling thought to think of the information that might one day come fluttering through our radio telescopes from an advanced civilization somewhere else. Any communication, I think, will be mostly from them to us, because they will have very little to learn from us and probably an enormous amount to teach us, not just in areas of science, but in other areas, some of which we can only dimly guess at today. I don't share George Wald's fears that such a contact would be a disaster. I think rather it's a supreme opportunity to learn something. But in any case, we can't hold back. We've already communicated our presence to the universe, because about 30 or 40 light years away from the Earth, there's a wave front of electromagnetic radiation which is moving away from us at the speed of light. This is the result of our first large-scale radio communications back in the 20s and 30s, and there's no holding that back. That indicates our presence. We've already communicated our presence to the universe. Now, we have before seen the difficulty in determining the presence of life on Earth photographically. Were we on Mars, just the same difficulty would be the case, but there'd be an easy way to detect life on Earth from Mars. You'd construct a small, modest radio telescope pointed at the Earth, and when the North American continent turned around towards Mars, there'd be this blast of radio emission, which would certainly not be totally random noise, due to domestic television transmission on Earth. It's a very sobering thought, I think, that the only signs of intelligent life on Earth detectable over large distances are the often baleful contents of American television programs and the radar defense networks of the United States and the Soviet Union. At the same time, though, I think that it would be very remarkable. Any extraterrestrial civilization would be able to see it. It's only in the last 40 years that the radio brightness of the Earth increased, and now it's increased at such a rate that at some radio frequencies the Earth is brighter than the sun. They would conclude that something extraordinary had certainly happened in the vicinity of the Earth. How would you send a message to space? What would you say? You obviously don't send out a message in English saying, are you chaps Presbyterians? For one thing, they don't understand English up there. There has to be some method of communication which both the sending and the receiving civilization have in common and doesn't depend on the vagaries of the languages at either end of the communication link. Now, if we use a radio telescope, then the receiving civilization has to also have a radio telescope, and that means they must have similar mathematics and similar physics. Suppose we design a message like this. Suppose we use two symbols, let's say 0 and 1, the basis of the familiar binary arithmetic. Let's let a tone of one frequency stand for the 0, and a tone of another frequency stand for the 1. We can then put together a message that might be something like this. Well, we can't make much sense of this message just yet, but we do notice that the message is repeated in several groups. Each group, each message, contains a certain number of zeros and ones. This number is 2,419. Now, there's something very interesting about 2,419. It's the product of two prime numbers. The two prime numbers are 41 and 59. And this is going to be a fact that's true regardless of what planet the mathematician who's analyzing this happens to be living on. Now, this immediately suggests that we arrange this sequence in a rectangular array, a square raster, so that we can see if there's any picture that comes out of it. If we arrange it one way and remove the zeros, then we get something like this. This is a picture which shows us nothing of any particular interest, no obvious symmetries, nothing to attract the attention of an extraterrestrial civilization. But suppose the message is arranged in another way. Suppose this message is arranged as 41 lines of 59 columns. Then the extraterrestrials might see coming off their computer a data analysis something like this. here we see a man, at least recognizably a man to us. Here is the sun, the orbits of the inner planets of the solar system, Mercury, Venus, Earth, and Mars. There's a line connecting the man with the orbit of the third planet, the Earth. All of this seems to be quite clear to us. There are some things which might not be clear to everybody on Earth. For example, this sequence of numbers here, 2, 8, 18, and 32. But certainly even an extraterrestrial with no prior familiarity with what people look like would be struck by the enormous order and symmetry of such a picture. It could not fail but to call attention to it. Now, this sort of message and much more sophisticated messages can be sent through space, but over what distances? If we imagine both sending and receiving civilizations using a radio telescope only as advanced as the most complicated one on Earth, the most advanced one on Earth, the Arecibo telescope in Puerto Rico, it turns out that communication could be established over the astonishing distance of 1,000 light years.